Elon Musk just revealed Moon Base Alpha's blueprint, and it's shocking NASA. The base isn't something Starship will build. Starship itself becomes the base. This 50-meter stainless steel cylinder transforms into a 15-floor lunar habitat housing 20 people, with its massive fuel tanks converting into living quarters and work areas. But here's the real question. How do you turn a rocket designed to fly through space into a permanent home on the moon? And what makes this approach better than traditional base concepts? This all started with a single post from Elon Musk that sent the space community into overdrive. Just days ago, he painted a picture of the moon's future that sounds like pure science fiction. Once there are lunar factories, robots, and mass drivers on the moon, such that the entire loop is closed, the system probably decouples from conventional currencies and operates autonomously in watts and tonnage. Wait, did he just say the moon would stop using dollars and start trading in raw energy and mass? That's exactly what he's proposing, a completely self-sustaining lunar economy. But Musk wasn't just philosophizing. He was expanding on something even more immediate: AI satellites. His argument is brutally simple and, frankly, hard to argue with. Satellites equipped with AI processors that beam only the results back to Earth will become the cheapest way to generate AI output within 3 years. The math checks out when you think about it. These satellites sit in sun-synchronous orbit with constant free solar power and ultra-low latency connections. They completely bypass Earth's biggest bottleneck, the desperate hunt for cheap, reliable electricity to power massive data centers. Here's where it gets wild. Musk claims this becomes the fastest path to scale AI within 4 years. His calculation goes like this. Launch roughly 1 megaton of satellites per year, each carrying about 100 kilowatts of power. That adds up to 100 gigawatts of AI computing capacity annually with 0 operating costs and 0 maintenance expenses. All of it connects back to Earth through high-bandwidth laser links via Starlink. The numbers seem insane until you realize SpaceX is already building the infrastructure to make this possible. Then comes the next evolutionary step, and this is where Moon Base Alpha enters the picture. Instead of launching satellites from Earth, you build satellite factories directly on the lunar surface. With robots mining lunar resources and a mass driver, essentially an electromagnetic railgun, you could fling AI satellites straight into orbit by launching them off the moon's surface. No rockets required, no fuel needed, just pure kinetic energy. The moon's low gravity and complete lack of atmosphere make this almost trivial compared to attempting anything similar on Earth. So how much computing power are we really talking about here? If that lunar production loop achieves full autonomy, running primarily on its own energy and materials with minimal reliance on Earth, the growth rate of total AI capacity could explode into tens or even hundreds of terawatts per year. That's not just incremental growth. That's the kind of scale associated with a Type 1 civilization starting to harness a meaningful fraction of its entire solar system's available energy. But none of this hyperscale future happens without taking step 1, establishing a real, functioning lunar base. Musk has said before that Starship will build Moon Base Alpha. Most people interpreted this as Starship delivering construction equipment and modules to the lunar surface. But what if it's more literal than that? What if Starship doesn't just build the base? What if Starship is the base? The moment you consider this possibility, everything clicks into place. Starship has massive internal volume already engineered to survive space. Using the vehicle itself as a ready-made habitat eliminates the complexity of launching separate modules, assembling structures on the surface, and integrating multiple systems. The base essentially launches itself, lands intact, and begins operations immediately. Now we get into the real engineering challenge. There are two main architectural concepts, and both have serious advantages. Let's break down the vertical moon base first, since that matches how Starship naturally lands. You're looking at a 50-meter stainless steel cylinder, with the top half originally designed for cargo, and the bottom half containing two enormous fuel tanks. After touchdown, those tanks transform into huge empty volumes ready for conversion into living and working spaces. Here's the structural constraint most people miss. Starship's design carries loads through the outer skin, which means heavy equipment must be positioned near the walls. All interior floors need to be thin and lightweight to avoid compromising the shell's integrity. You can't just build normal flat floors like a conventional building. Instead, the optimal layout resembles a lighthouse, a spiral staircase or ramp running around the inside perimeter, creating easy movement between multiple levels while maintaining structural efficiency. For initial missions, you could fit approximately 15 floors inside. Musk has mentioned Starship could theoretically carry 100 people per trip. But let's be realistic. Nowhere near that many individuals will qualify for early lunar missions or even want to go. With 15 floors, you're looking at comfortable accommodation for 16 to 20 crew members with room to spare. The zoning strategy is brilliantly practical. The very top becomes a quiet observation area, a small room with viewing windows and minimal storage directly below. This provides psychological relief and scientific observation capabilities. The next levels down house sleeping quarters, compact but well-designed cabins featuring a bed, desk, and porthole. These stay far from noisy mechanical areas, and water storage surrounds them, providing dual functionality, life support reserves, and natural radiation shielding. Why use water for radiation protection instead of specialized materials? Simple physics. Water is incredibly effective at absorbing radiation. It's already required for life support, and it serves multiple purposes simultaneously. One layer doing 3 jobs beats 3 separate systems every time. Below the sleeping zone comes the social and operational heart, a combined mess hall and recreation space with full galley and food storage. This isn't just about eating. It's about crew morale during months-long missions. Under that sits the work deck containing desks, science labs, and a small medical facility. Lower still, near the main airlock, you find heavy equipment, storage, tools, EVA suits, and cargo staging areas. Waste management systems occupy this level too, using gravity to assist with water drainage. Another elegant solution using physics instead of complex pumping systems. Inside the former fuel tanks, the ship suddenly offers multiple tall, open volumes. These cavernous spaces could eventually house life support machinery, spare parts, 3D printers, storage racks, and long-term equipment reserves. Mesh floors and built-in cranes facilitate moving items through these chambers. Finally, at the very bottom, inside the skirt, an unpressurized garage for rovers connects to a large ground-level airlock that vehicles drive directly into. This design avoids hauling heavy rovers up a 28-meter ramp just to reach the crew airlock, a seemingly small detail that saves enormous time and effort during surface operations. But wait, what about the horizontal concept? Many lunar architecture experts actually prefer this approach, despite requiring the extra step of laying Starship on its side. Here's why it might be superior. After landing, robotic systems prepare the surrounding terrain. Large rocks get cleared, ground gets leveled, and 2 berms are constructed on either side to stabilize the horizontal configuration. Most construction equipment arrives already stored inside Starship. The crew mainly brings life support systems, suits, additional supplies, and transportation like rovers. After the horizontal maneuver, all methane fuel gets completely drained and stored in designated bladders. Any remaining fuel in the tank gets vented, ensuring total elimination of fire risk during interior modifications. The nitrogen in the payload area gets replaced with oxygen from the tanks, while the oxygen tank receives nitrogen, achieving proper atmospheric balance and pressure. The methane tank also gets pressurized with breathable air through its refueling port, transforming former fuel storage into habitable space and dramatically expanding the base's usable volume. Here's the game-changing advantage. With a horizontal orientation, Starship's 9-meter diameter allows division into 3 full floors, each roughly 3 meters high. That's actual standing room, not cramped spaces. Water tanks install on the upper floor, providing radiation protection for levels below. Once floors and tanks are positioned, cables and pipes for communication, electricity, ventilation, and water distribution complete the internal structure. But the horizontal concept's real superiority emerges with regolith coverage. You can bury the entire structure under a 3-meter thick layer of lunar soil. This regolith provides protection from micrometeorites, creates a barrier against extreme temperature swings, and adds substantial radiation shielding. The moon's temperature ranges from 127 degrees Celsius in sunlight to minus 173 degrees Celsius in shadow. Regolith insulation makes this survivable without massive energy expenditure. Critical engineering note here. Habitat systems and complex components can't be buried directly under regolith because future maintenance would be nearly impossible. Passive systems like fluid lines, vapor lines, power cables, grounding lines, and structural footings can be safely buried. But any components requiring inspection, operation, or maintenance, valves, connectors, joints, active systems must sit at least half a meter above the surface for access. Using regolith for radiation shielding isn't as simple as piling dirt on top either. It requires building a proper superstructure and carefully filling it to ensure effective, uniform protection without creating structural stress points that could crack seals or damage systems. So what's the actual operational capacity here? A lunar Starship base could comfortably support a dozen or more astronauts for extended surface stays. But what would they actually accomplish there? This is where the economics get fascinating and, honestly, pretty shocking. If one Starship-based habitat supports approximately 20 people for 6 months at a time, the entire program might operate under roughly $150,000 per person per day. Compare that to the International Space Station, running around $10 million per person per day. That's not a typo. We're talking about a 98.5% cost reduction. And here's the kicker. A low Earth orbit station built from similar Starship hardware would be even cheaper simply because it requires far less energy to reach. But there's no reason to stop at one lunar habitat. A long-term program could land perhaps 4 Starships per year, each customized for specific missions and upgraded based on lessons learned from previous deployments. Over time, you could establish a complete network of self-sufficient habitats around prime locations like Shackleton Crater's rim. If the landing legs can articulate, and there's no engineering reason they couldn't, the vehicles could literally walk closer together after landing and connect via pressurized tunnels, creating an expanding base complex. With a rapidly growing fleet of Starships and cargo variants, SpaceX is positioned to lead humanity's first true base camp on the moon. And as Starship upper stages begin serving double duty as lunar orbiting stations or even as spectacular lunar resorts, SpaceX could easily outpace NASA's more conservative plans for minimal astronaut habitats at the lunar South Pole. Elon Musk has already picked a name for his moon base, Ota City. Whether that sticks or not, the vision is crystal clear. We're not talking about flags and footprints missions anymore. We're talking about permanent human presence on another world, enabled by a spacecraft that literally transforms into the infrastructure it delivers. Think about what this really means. Within the next decade, we could see Starship habitats dotting the lunar surface, connected by pressurized tunnels, housing dozens of astronauts and scientists conducting real work for months at a time. The cost reduction alone, from $10 million per person per day on ISS to $150,000 on the Moon, fundamentally changes what's economically possible. That's not incremental improvement. That's a complete paradigm shift. And this is just the foundation. Those lunar factories Musk described, the mass drivers flinging satellites into orbit, the autonomous economy running on watts and tonnage instead of dollars. It all starts with getting humans living and working on the lunar surface sustainably. Moon Base Alpha isn't the end goal, it's the launch pad for everything that comes next. So here's my question for you. Musk went with Ota City as the name. Got something better? Drop your moon base name ideas in the comments below. And if this vision of humanity's lunar future got you fired up, smash that like button, share this with anyone who needs to see where we're heading, and subscribe to New Space Review so you don't miss what happens next. The countdown to Moon Base Alpha has already started.